Welcome to the Fed to Fed podcast, where we dive into the dynamic world of government technology. In this podcast series, we'll be joined by current and former federal leaders and industry trailblazers who are at the forefront of innovation. Here, we speak openly and honestly about the challenges and opportunities facing the federal government and the Department of Defense and its partners in the modern age, driving innovation and the incredible capabilities of technology along the way. Whether you're a federal leader, a tech industry professional, or simply fascinated by IT modernization, just like us, this podcast is for you. And we're so happy to have you tuning in. As generative AI adoption accelerates, federal agencies face a mounting dilemma: soaring OPEX from hosted LLM services, limited transparency, and brittle integrations. This discussion explores how Agentic AI offers a more sustainable, modular, and mission-aligned alternative. We'll cover three pillars of transformation: architectural modernization, cost control and CapEx realignment, and operational autonomy. To ensure safe deployment, this session will emphasize the role of policy-driven guardrails, adversarial AI oversight, and composable governance patterns that align with Executive Order 14028, the AI Risk Management Framework, and OMB M-25-21. Federal CIOs must modernize AI architectures, not just AI apps, if they want scalable, secure, and audible automation. Ben Cushing, thank you so much for joining us today.
Happy to be here.
I'm really excited about this discussion, and let's jump right into the questions. So, Ben, why are agencies drawn to AI systems that can process vast context windows and generate insights beyond human capability?
It's to augment human beings. There's so much complexity in the world we live in. There's so much knowledge that exists already and is being produced every day. The amount of complexity and knowledge that we encounter surpasses our ability to perceive the world around us completely and holistically. And a large context window within a large language model service, or any large language model, allows for more information, more context to be provided for a richer response from any one of those services. An example of that might be if you were really interested in soccer. So not a topic I talk about a lot, but if you're interested in soccer, you start asking about one game, then you're going to get responses about one game. If you ask about the trends of soccer over hundreds of years, then the context window is going to increase as you put more and more information into the prompt. And the LLM service has to hold on to the running conversation that you're having in order to have more rich conversation. You can also think of a context window in the same way we have a conversation with each other. So when you start talking with somebody, if you have a conversation that lasts for 4 hours, that's a much larger context window. And when somebody references something at the beginning of the conversation, they're expecting you to pick up on that and respond to it or close out a thought from the beginning. That's how you have a more rich dialogue versus the small talk of like back and forth, how's the weather? That's a small context window. So I think that in order for large language model services to really serve us properly, we're going to need to continue to increase those context windows. There's significant costs associated with that and technical challenges. One of we're here to talk about agentic architecture. That's something that will inevitably help with those context windows. So we'll come back to that in a second, I think, as we get through these questions.
That sounds great, Ben. So how does the history of software from monoliths to microservices help us understand today's challenges with LLM-based applications?
Right. So, I'm touting the brilliance and how great LLM services are, but unfortunately, we've created a new monolith. So, for those who have done any sort of application development, programming of any kind in the last 25 years, there's been a general movement away from creating large applications that are difficult to test, very difficult to debug, very costly to run. They use a lot of memory. difficult to move around. Like in terms of their portability, those applications require pretty large, substantial runtime. So over the last 25 years, the practical decision, or there was a practical decision made by the community that we should be using microservices instead. And so there's a very common practice within modernization of IT services where you deconstruct the monolith. The more colorful way to say that is, people say, "We'll strangle the monolith." I don't know why they went with that, but it's pretty accurate in the sense that you're taking this monolithic application, you're isolating specific features of that application, and then you're extracting them from it into a microservice that then gets referenced by the larger application. And over time, you're pulling more and more parts out of the monolith until you have a deconstructed an array of microservices that together still do the same thing the application did, the single one. But they've all been pulled apart, and each one of those microservices runs as its own software application, meaning that it has its own lifecycle. You test each one independently, and then you can test them as a group. And in this way, we're able to solve some of the problems I just mentioned. Like we're able to have a more succinct software lifecycle for each one of those applications. Testing is a whole lot easier because you're testing each individual part, and then you test the whole. It's a lot easier to debug because you can find a bug within the single microservice. And traditionally, if you found a bug in a monolith, it takes forever to find where that bug might be because you have to look over the whole thing. You can't just go right into the microservice that's already been pulled apart. Also, these microservices are a lot more portable. So we can now pick and choose different features that we want depending on what's necessary for the environment where the application will get deployed. So the hardware can only support a third of the features, then pull a third of the features from the microservice architecture and just deploy those individual microservices within that edge location. So, and going back to LLMs, we kind of messed up in the sense that we're still doing it. Like these large language model services get bigger and bigger. I think right now GPT-5 is about 163 billion parameters as a model. That's a huge LLM. That there's some good stuff there. It means that it's very smart. It can talk about tons of stuff. It has incredible amount of knowledge baked into it. To run that model, you need like a lot of memory to just have it running in real time, and all of the services that are attached to it to make it function for all the different users that are hitting that model or instances of that model requires also a lot of resources. So the technology companies that run those kinds of services are also starting to build up agentic services along that to try to kind of do what I'm describing here. But I'm gonna take a different tact in that I'm gonna say that those large language models have probably reached a plateau of size where it's like really useful to have a model that big. I think we've reached a plateau where it's just like at a certain point, the model does not need to get bigger and bigger. It doesn't need to know that much anymore. There's of course an endless amount of knowledge and things we could pack into it. But if we start to think about how to create microservices from an LLM, you start to think about domain specificity, meaning that instead of a huge large language model that knows everything from physics to gardening, we have a couple small language models that know something. One of them knows something about physics, and one of them knows something about gardening. And we run them together in a microservices architecture. And now the system knows about gardening and physics, but each one of those models is independent of each other, has its own software life cycle. Each model can be tested, each model can be audited, things of that nature. And what I'm describing here is not necessarily agentic, but it is the decomposition of a large language model into smaller nodes. And together, they have the same effect as a large language model, but are easier to manage. Agentic itself is when you start to use these models to take action. So agentic, if you break down the word, it means agent, right? It's like these are a bunch of agents What do agents do? They do stuff, right? So each one of these little agents is responsible for maybe processing some data or reviewing content or querying an external tool to do something like, hey, go open a ticket with ServiceNow or send an email, right? That's what the agent's for. But each one of those agents has generally a large language model or a small language model associated with it as the thinking center. So when you start to create agents that have domain specificity, like let's say there's maybe like 6 or 7 agents that do gardening and 6 or 7 agents that do physics, right? Those little pods of agents are, again, relying on a small language model that knows the domain specificity. And when you combine them together, you then have a more nuanced view of the world. Large language models, when they first were developed, they're of course based on deep learning, which is based on neural nets. Neural nets are, the idea behind them are to try to mimic the way the brain works, right? You have layers and layers and layers of thought. What's kind of interesting is that agentic architecture, the way I'm describing it, is also very similar to the way the brain works, in that you have individual nodes that are responsible for a single thought, and they're connected to each other and they communicate. So I'll say when we get into this microservice architecture and we apply agentic concepts to it and it starts to act, one of the really neat things is the convergence of this existing application development cycle, turning monoliths into microservices and developing agentic. And a lot of the things we learned in the microservices world will apply directly to agentic development.
Oh,
so
wow.
Things like policy, right? Like we can create a policy that all the agentic systems have to follow. Governance of the agentic systems, traceability, logging. Like every time one of those agents communicates to another agent, it creates a log. We know what they thought about, what they told each other. We know it explicitly. It's not implied. We know exactly what they said to each other. In a large language model system, you can ask the large language model what it was thinking when it came up with the answer, but it has to think in order to produce the answer for you. Meaning that when you do the audit, it can hallucinate in the audit too, which is obviously not great. Like there's plenty of examples of people recording large language models lying about what they were thinking to protect themselves. In an agentic system, the communication from one to the other is a rote IT task. That communication happens over a network, and that network will record what happened, what was said, and now you have an audit trail.
Wow, that's awesome. Thank you for breaking that down for us, Ben. So, Ben, what are the risks of treating LLMs as monolithic applications? And what lessons learned can you take from past modernization efforts?
I think I dovetailed into this question like accidentally with my previous response, but I'll just add that the risks are that we just keep leaning more and more on resource consumption to the point where models are just too large to run and maintain a profit margin. What's not really clear when you interact with Anthropic, Gemini, OpenAI is those companies aren't making money. They're they're losing money because the amount of resources they use to run those services far exceeds the amount of money they're getting in subscriptions to those services. They're still really trying to figure out the business model. So I think the risk we run is making that worse as we build out more larger models. The other thing too is the longer we wait to embrace agentic, the longer we accrue tech debt, right? Like usually when it comes to decomposition of monoliths, IT organizations and enterprises treat that as technical debt they have to attend to. The longer we wait to do that same process with LLM services, the more technical debt we accrue. And then we have to go back and readdress it over another 20 years or however long it takes to decompose these monoliths.
Wow. So, Ben, how can agencies structure AI use in a way that keeps operational costs manageable, even as demand skyrockets?
Yeah, so there's a value trade-off here that is worth discussing. So when you use an LLM service, that's usually paid for through OpEx, meaning that your operational costs include the LLM service itself. Okay. If a federal agency has a contract with OpenAI, they generally go into that with some idea of what they're going to spend month to month. They set up a contract with the large company, in this case OpenAI, and then start to they turn on the service for users. Users start to use it, and as you might imagine, it becomes very popular. So popular, in fact, that it exceeds the resources that OpenAI and that agency negotiated. And then OpenAI says, hey, we either have to throttle the use or we have to renegotiate because we can't afford to just keep giving this to you. It's way more than we expected. I think I can say safely that that has happened almost every single time that an agency has contracted with an LLM service. It's because these things work. They're incredible. They help people, they augment our abilities. There's an endless amount of faux pas that people do with them, but that's, those are like, I think those get lost in how practical and useful the tools are. And that's all under OpEx, okay? Now, the way to deal with this is there's a like I said, there's a value trade-off that occurs. When you start seeing your OpEx costs exceeding the CapEx expenditure for building your own service, then it becomes a build your own scenario where these are completely made up numbers, but like, let's say you're spending $40,000 a month on OpenAI and you have tons of users that have exceeded the limit, your OpEx is ballooning. You then say, okay, well, if I put down a couple $1,000,000 to build my own service that does the same thing or something like it, how soon will I recoup the actual $2 million if I compare it to the OpEx cost, right? So it's just basic mathematics. And agencies are getting to that point. There are a number of commercial entities that have reached that point already and have decided we're just going to build our own. And to their benefit, there are a lot of tools already available to them to do just that. The open source community has responded to this new AI, or I should say Gen AI space, and it has developed many tools. A lot of them, in fact, are used by Google and Anthropic and OpenAI to run their own services. So you can actually go get those AI tools yourself. And given that you have the skills, the right partnerships, and the money, you can do your own service. And that's where the OpEx versus CapEx conversion is generally happening.
Wow. Thank you for that. So, Ben, if you had to pick one, what's the non-negotiable governance control for agentic AI?
Okay, so I think I said it already, but like Agentic is the new app dev in the sense that we're building applications. Each application has some relationship to an AI, some kind of AI, like whether it's a predictive model or generation, what am I saying? A predictive model or a Gen AI model or small language model, large language model, whatever. Each one of those agents, for the most part, especially for the large language models, are probabilistic. All right. Meaning that you can ask an LLM the same question and you'll get a different answer each time. Not to say the answers are wrong, just that each answer is different. And if you're an enterprise and you have to test the output of lots of little agents that are producing some sort of, they have a query that comes in and then they produce a response. In order to test that they work right, you need the response to be pretty much the same every time, right? Otherwise, you can't test the validity. And so I would say a non-negotiable is not having some form of adversarial AI in the chain of thought that occurs within an agentic system. Now, the amount of adversarial AI you put in there is entirely, I would say, application specific, but I can give an example. So just did a presentation at HIMSS this year where my colleague and I had built an agentic system specifically for filling medication orders. And within that system, we had one agent that was adversarial, and its job was to validate the output of a medication order following the FHIR standard, which is a healthcare protocol. And it did two things. It reviewed to make sure that the FHIR format had been followed explicitly so that it could be sent to the electronic health record. It also read through the content of that was produced to make sure that the fields were properly written to the right keys. So it's essentially validating the data output. And that's all it did. Its job was just to validate the output. And running the system a number of different times, it did its job. It would, maybe 30% of the time discover malformed information coming from one of the other agents. And it would say, nope, this is wrong. It would send it back and say, hey, you screwed up. This is where you screwed up. And then the other agent would be like, oh, so sorry, and would produce a new output and send it and it would get checked again. That for me, that's non-negotiable. Like that's how you create trust in a system. And if we can't have some level of trust within that system, no one will adopt this stuff. What's really nice about what I just described is that adversarial AI can follow like a human type check, right? Like it can act like an informaticist, a doctor, or somebody else who might be reviewing content. There's of course other controls that have to be in place that are sort of like table stakes, I should say. Like, for instance, looking for any sort of malicious injection. So like if somebody writes code into a prompt and that code is looking to get executed by the system and then mess it up, that needs to be checked for, of course. You also want to have like policy check. So if your system, the example I used earlier, if the system knows a lot about physics and gardening and somebody asks a question about music, well, the system should be able to say, hey, I actually don't know anything about that. But those are sort of upfront filters that you need within the system itself, which again, each one of those filters is an agent. And one of those agents has registered the domain expertise of the system. It can say, hey, this query relates to something we don't know anything about, and it should respond in kind to say, I'm not sure what that is.
Very, very cool. So Ben, in closing, what emerging architectures like AI microservices could provide a path forward for scalable and sustainable AI adoption? And what are the practical steps for scalable AI adoption?
Yeah, I would say if you're just getting started, the best way to consume AI today is by far to use a service. There's plenty of services out there. I think, especially in the federal space, Google and Anthropic and OpenAI have gone. They've really stretched themselves to accommodate the federal requirements for multi-tenancy, for security controls, for data leakage, things like that. I can't say that they've solved it on the back end because I can't see that, but I'll say that they've taken all the right steps at least. So I would say using those services, great use. It will help you understand your user base. It'll help you understand the use you can expect from constituents. It will, you'll start to see the value and impact of it pretty quick. That's step one. Step two, in parallel, I highly suggest doing pilots where you start to link a large language model that's deployed on a local system to RAG, or retrieval augmented generation. When you combine those two things, you're able to retrieve knowledge very rapidly. It's a very low cost way to start doing AI. And I mean, I could say from experience, like having been engaged with a few of those, you have immediate impact for customers, meaning that, and by customers, I mean like constituents, consumers, whatever, whoever is the group you're serving. Almost immediately, you can start to extract information from a seemingly endless array of information and getting it contextually and put it in the hands of the person who needs it. You can do that really quick. Examples of this would be like, let's say there's policy. Let's say you've got a mountain of policy documents. And whenever somebody needs to query that policy, it requires a human being with 30 years of experience to be involved in the conversation. Well, all that policy can be loaded into a database, into a vector database, and then queried through a large language model. And you pretty much get like a subject matter expert response. You probably want to review that before you give it back to a consumer by a subject matter expert. But in this case, they're doing the review of the content. They're not spending hours and hours reviewing the policy. Okay, so it's just like immediate value right there. As you start to work with that kind of system, you're going to discover that you want to add other knowledge sources and you want to add other services. And now you're kind of walking into an agentic space where, oh, I need a way to communicate with that data that's more flexible. I need these individual models or services to talk to each other because the question that was asked is too complicated for a single LLM and database. I need a couple of these to respond in kind. And now you have an agentic requirement. And like I said before, the open source community has already provided these tools. So they're all out there and available to work with today. But that's something that you'll walk into as you take these steps. I think it's a fallacy to just build an agentic system right off the bat without any sort of testing and need. But I think agencies, commercial entities, everyone will find themselves in this place fairly soon if they're not there already.
That's great, Ben. Thank you so much for joining us today. And I look forward to future discussions around Agentic AI. And for people to gather additional information about Agentic AI, hit the QR code below in this post.
Thank you, Susan.
You betcha. This concludes today's episode of the Fed to Fed podcast. If you enjoyed this episode, please don't forget to subscribe, rate, and leave a review. Your feedback helps us continue bringing you thought-provoking conversations with the brightest minds in government technology. Stay tuned for our next episode, where we will continue to explore opportunities to harness the power of technology and explore what's next in developing a more innovative and efficient government. Until then, this is the Fed to Fed podcast by GovTech Connects. Thank you for joining us.